Hello, everyone, and welcome to another Jscrambler webinar. Today, we'll be talking about obfuscation with some focus on debunking the free obfuscation myths. All right, so this webinar will take around 1 hour. And prepare ourselves for some online polls. We want to make this more interactive, and we want to give you also some opportunity to participate. At the end, we will also have a Q&A session where you will be able to place some questions, and hopefully we'll be able to answer them. And after this webinar, you will also receive an email with a recording of the event. And also, as a bonus for your participation, you will also get some additional resources on obfuscation. So today, we'll be having 3 speakers, both of us working at Jscrambler. So starting by myself, I'm Gustavo Marques, and I am a product manager at Jscrambler. And with me, I also have Katia Kupidonova, and she's a product marketing manager, and also Jeffrey Cleveland, our pre-sales engineer. A little bit about Jscrambler. So at Jscrambler, we position ourselves as the pioneering platform for client-side protection and compliance. We cover both first-party and third-party code protection. And when it comes to first-party code, or as we also refer to it as source code, we offer comprehensive future-proof protection against client-side JavaScript threats and risks. And with our first-party code protection technology, the way we designed it is actually to safeguard your hard-earned online competitive advantage, keeping your code safe from malicious actors. And we achieve this through a combination of powerful obfuscation techniques, strict environmental integrity checks, and also dynamic runtime code protection. And that's actually what our code integrity solution offers. Protection from tampering, from debugging, reverse engineering, and even more. And so our priority at Jscrambler is to keep the web applications of our customers secure, while also ensuring compatibility across various script frameworks and languages. And we do all of this without impacting the performance of the applications. So with our advanced obfuscation tools, we aim to ensure that developers can actually implement robust security measures in the applications with peace of mind. And by doing so, we not only strengthen the protection against reverse engineering and data breaches, but we also promote user confidence in a digital environment that is now ubiquitous, but challenging and susceptible to threats. So bringing together all this technological innovation and our security expertise, we are committed to make the internet a safer place for everyone. And today, as I mentioned before, we'll be talking about obfuscation and how this obfuscation works, how it's used to protect the intellectual property, and also to contribute to software security. And we will also be focusing the challenges and threats that can arise when using free obfuscation solutions, which do exist, are affordable, and solve the problem. Well, do they really solve the problem? Let's find out. So now I'm going to pass the word to my colleague Katia, who will be talking a bit more about obfuscation. So go ahead, Katia, stage is yours.
Thank you, Gustavo. Hi, everyone. Let me start by introducing the subject. In simple terms, obfuscation is a technique for transforming the source code of a piece of software to make it difficult for humans to understand, but still readable for the machine to run it. And this process aims to protect sensitive information in the code, to make sure it is protected from malicious attacks and manipulations. Obfuscation is crucial for several reasons, from protecting intellectual property to preventing reverse engineering. And the goal is to make it increasingly more challenging for hackers to understand how the software works and mitigate the risk of various client-side attacks. It's important to note that obfuscation alone is not an all-around complete security solution. So just as vulnerability scans are necessary but insufficient, obfuscation should be used in combination with other security practices. Today, among the most popular open source free obfuscation tools, we have obfuscator.io, uglify.js, JavaScript obfuscator, and some others. I'm sure you've heard about some of these if you researched obfuscation. And I think this is the time for a little mini poll. The question is, for our audience, how many of you are currently using open source obfuscation tools? This is optional, of course, you don't have to answer, but it's interesting to see. I'm sure some of you are considering, but not using yet. Yeah, we can check the poll results a bit later. Let's move forward. So there are several myths associated with free obfuscation tools that can create an impression a false impression about the effectiveness of these free obfuscation tools. And the first one is free obfuscation is as efficient as the paid solutions. And this one comes first because the idea that free obfuscation tools offer the same level of protection and security as paid solutions is quite pervasive. And of course, it is not true. In reality, free tools are generally they offer very limited features and functionalities and do not provide the same degree of protection against reverse engineering and sophisticated attacks. Unfortunately, those attacks become more dangerous with the rise of AI. Moreover, because they obfuscate one file at a time, integrating them into large-scale web applications becomes challenging because these web applications depend on continuous JavaScript development, release, and maintenance in extensive production environments. That means that free obfuscation tools are rarely, if ever, easy to use and take up developer time. So the question is, would you rather get it done fast and efficiently and not waste developer time, or suffer a bit of frustration with the open source tool? Another one, myth number 2, is free obfuscation tools are enough to protect my code. Well, some people believe that by using a free obfuscation tool, their code will become immune to attacks and threats. However, it is important to remember that obfuscation is only one layer of protection, and it does not offer complete security, and it does not protect you from all kinds of threats. Recently, a customer of ours shared that before choosing us, they found a free deobfuscation tool online and used it to test the obfuscated code that was initially obfuscated with one of those open source tools. And they were quite disappointed when they saw that things fell apart quite easily. So when that one, obfuscation layer was removed, there were also no runtime defenses to bolster protection. And in many industries, unprotected code like that is basically an invitation for fraudsters to attack. They're waiting for their lucky moment. So let's move on to myth number 3, which states obfuscation makes my code 100% secure. Again, there is a mistaken belief that by obfuscating code, it just becomes completely inaccessible, completely immune to attacks. And although obfuscation makes it really difficult to understand the source code, experienced attackers can, in some cases, overcome these barriers and identify vulnerabilities and get to the sensitive information. Ideally, obfuscation should complicate the attacker's life so much, to such an extent, and make the process so complex and time-consuming that the attacker is just, it's easier for them to abandon the attack. That's the goal. Another myth is that obfuscation doesn't affect the application's performance. Although some obfuscation techniques have a minimal impact on performance, others can cause an increase in execution time and resource consumption, thus impairing the security of the app that they're trying to protect. Often these tools lack support for controlling file size inflation. Consequently, they frequently result in in-control file size expansion, sometimes up to 7 times the original, causing, of course, substantial lag that affects the overall performance of the web application. Another little poll for the audience. What concerns you the most about using free obfuscation tools? Is it a safety issue only for you, or maybe lack of technical support, or maybe other concerns? That'll be interesting to see. I think, Gustavo, we can come back to those polls as well at the end, right?
Right, yeah.
Yeah, okay. Okay, let's move on. So to sum up, when using free obfuscation tools, it's important to consider the disadvantages. You have to think about resource limitations. Free tools generally offer limited resources compared to professional solutions. This can mean that certain important functionalities may be unavailable or restricted, affecting the quality and effectiveness of the obfuscation. When opting for a free tool, it's important to remember that the technical support is most likely very limited. This can make it difficult to solve problems quickly. This can be a bit frustrating when you can't get assistance if you run into difficulties using the tool. You also end up receiving less updates, less improvements, which can result in absence of bug fixes, for example. And in between comes also one of the most complicated disadvantages of using free obfuscation tools, which is unsatisfactory security levels. Free tools are not as rigorously tested and audited as commercial solutions. This can lead to greater risk exposure, especially if the tool is used improperly. Lower levels of security and protection endanger the customer data, people who visit your website, and the intellectual property of website owners, meaning the company you work for. In addition, some free tools may have poor documentation and a less active user community, which makes it difficult to learn and share knowledge to make sure you maximize the value of using the tool. Something to be aware of, free tools may be made available by unreliable sources and may even include malicious components. So it's very important to remember that you have to obtain tools from reliable, trusted sources and to check the integrity of the files you download. Another important point to think about is in free tools, it's very common for obfuscated code to become unmanageable for a human being, but it still can be very easily reversible by a machine. And it's increasingly common for attackers to develop programs to obfuscate the code rather than, trying to interpret it manually. So in conclusion, the lack of an effective solution can create a false sense of security. The consequences of using certain free tools can be even worse than not using any tool at all due to the vulnerabilities they can introduce. And it's basically an open door for an attack or criminal abuse. And generally free tools fall short in terms of security, support, compatibility, integration, documentation, ease of automated reversion, and most importantly, performance. And in rarer cases, they add the risk of malicious code being introduced, so we have to be aware of that. I'll now hand it over to Jeffrey, who will share with us a little bit more details about the obfuscation technique itself.
Helps find me. Thank you. Yeah, so we've talked a little bit about some of the myths of free obfuscation tools, but I want to talk about obfuscation a little bit more in general. So this will be kind of like a little introduction if you're not terribly familiar with obfuscation or the algorithms that back it up or why it's used. We're going to get into that a little bit. So I've got that simple definition of obfuscation there, and that's the process of making source code more complex, unreadable, and difficult to understand. Something that's important about that definition, though, is that we want it to be hard to understand the source code. So by reading it, static analysis, or a debugger. We don't want it to be difficult for a browser, or say you're making an Electron app or a hybrid native app. We still want those uses to be very easy. We want them to be very performant. We want someone who's using your code in the way that you intend to get the intended result very easily. So why obfuscate in the first place, right? And the first step to exploiting any piece of code is understanding that piece of code. You might be looking for vulnerabilities or other processes that you can exploit in order to carry out an attack. You might use debuggers, you might use built-in developer tools, a lot of options for reverse engineering, and all those ideas come together to define that idea of reverse engineering. So once we understand that code, then we can start to design an attack against it. And I've got 2 examples of those attacks here. One is simple intellectual property theft. You might have the best video player out there, you might have a very clean checkout process, or maybe you have a really good security or analytics tool. But there'll always be someone out there who wants to, kind of skip the hard part and just copy your own implementation, whether they're doing that for themselves or whether they want to make a commercial product using the same techniques. From there, I've also got tampering as an example of an attack, and that can lead to a number of different problems with code. Just to use some of the same examples, go back to that checkout process. I might inject extra code that sends credit card data or other personal information over to a separate server. I might want to disable security or analytics tools in order to go undetected. Or I may want to be able to inject code into a video player to bring video outside of that player in violation of copyright or other laws. So kind of as a first step, obfuscation is a great way to raise that cost of reverse engineering and in turn raise the cost of intellectual property theft, tampering, and other attacks. But how does obfuscation work, right? So there's a lot of different techniques and algorithms out there for implementing obfuscation. I've got a selection of them here to talk about. And the first one's renaming identifiers, which very simply takes identifiers like variables, functions, or classes and changes them to something meaningless, right? So someone who's going through the code might examine a variable or otherwise and need to change that into something of their own naming convention in order to start understanding that code. Splitting functions is exactly what it sounds like, where we take a function, break that into a lot of parts, and scatter that through the code, maybe out of order, right, to make it very hard to put those pieces back together. Inserting false instructions could also be termed as inserting dead code, and this adds code that will never execute, that the legitimate execution of the application will never reach. But if I insert something like a debugger, or if I just take out a section of the code and try and execute it on its own, I might get trapped in a loop or trapped in a section that really doesn't mean anything to the function of the code itself. Mixing code and data allows you to take things like constants and other variables and put them in between other functions that will make extra confusion around determining what variables control what functions and vice versa. Injection of redundant code, similar to false instructions. It's code that is exactly like other code within a file or within a project, but makes it very hard to understand which copies of the code are actually used and which ones are skipped inside of the control flow. And then in hiding control flow, this can be a very simple implementation or very complex. One of the more complex implementations of this type of obfuscation technique involves taking every function and having it called by a central control function where you store some control variables that decide what function goes next. And when those functions complete, they return information back to that single control function that decides what is the next step inside the application. But without being able to understand each of the functions that work under that one central controlling function, it can be very hard to determine what's the next step, what's next in order, what is the next step in the control flow. So it's very important that you have a lot of different options when you go to obfuscate. One or two methods by themselves may not be very useful, but certainly combining these, say you have control flow combined with splitting up a function, it can be very hard to determine, where is this process actually started? Where does it terminate? When does it come back to this central control function, and to really begin to understand how the code works. And that makes it more effective of a protection. And that could be a limitation of free tools. You may just not have many options, and that can lead to other issues. Performance is a huge consideration when it comes to any type of obfuscation. When you obscure code, you will have some kind of increase in that code size. That can affect load times, and it can certainly affect the way it's being run, right? If we're completely restructuring the code, if we're adding new functions or splitting certain functions up, that adds instructions. And so you want to have many different options. You want to have many different tools and ways of determining what that effect is so that you can get things tuned for your particular use case, make sure that that piece of the application is still just as functional as it was before. Effectiveness, we've kind of touched on a little bit, and you can measure that in a lot of different ways. Is it effective against someone reading the code, just a human? Is it effective against things like debuggers? Or is it effective against large language models like ChatGPT or other AI tools that are able to begin the process and make it easier for a human attacker to either find other tools or start down certain paths to taking that code apart? And then the last one's compatibility. And this is one that we see most often in a difference between free tools and a tool like Code Integrity, is that they may not always be compatible. And that can refer to simply the framework that you're using or to intermittent issues between builds. You may get a solid build out of a free tool that is performant, that might be effective, that works, but then you run the next build and now your code doesn't work anymore. So now I've got to dedicate more time from developers to fix that CI/CD process, to go back and redo the options that we're choosing in obfuscation in order to get that good performant build. I might add new sections of code. I might add new microservices, and now the code doesn't work or just isn't performant or usable to the end user. And if the user can't get the intended result, then there's really no point in protecting the code in the first place. And of course, the JavaScript is an interpreted language, right? It's very easy to get your hands on the code itself. And in this example I've got here, it's very easy for someone to go through and examine a widget that exists on a page and say, hey, I can understand exactly how this form works. I could design a piece of code that goes in here to send me the results of this form or to modify it in a certain way or be authenticated when I shouldn't. And we've seen these types of actions play out in real scenarios. One of the more recent ones that we dealt with is where grade school students were able to use built-in browser tools, use the built-in developer tools to cheat on tests and assignments in this same manner. And so, of course, those consequences get worse and worse as we start to talk about payments, login information for things like banks or other personal information that could result in higher ramifications, fines, fees for various regulatory bodies. And so kind of the last thing I want to discuss is we've talked about pure obfuscation on its own is a good passive way of protecting your code, but that may not be enough. There's two additional items that we take a look at. One is polymorphism. A lot of free tools generate the exact same solution to your code when you obfuscate. And that can make it very trivial for an attacker to decide, hey, here's what's being updated, here's what was fixed or patched in a certain version. With a tool like Code Integrity, we use that concept of polymorphism to make sure that you get a different resulting protection every single time you run that protection. Whether a file or section of the code is changed or unchanged, it will appear different to an attacker. Well, we can go another step further, and we can include additional logic, additional code that allows your code to detect when it has been tampered with, when the browser's native API has been tampered with, or when someone's using a debugger against your code. And with that additional logic, you can either choose to repair that code or pre-program it with countermeasures that allow you to either take actions against that manipulation or repair. When you decide to take actions, you may decide, hey, this checkout session has been modified, and so I want to redirect the user out of this checkout session. I want to log them out. Or maybe they're inserting code into my video player, and I don't want to continue playing the video in that case. So maybe I break the code, or maybe I force them to log out. And then I can send myself an alert, so I can say, hey, if we get a lot of these alerts, maybe we need to take further action. And that gives us some visibility out on the edge where that didn't exist previous. Katya, I think I'll hand back to you.
Back to me. Thank you, Jeffrey. And yeah, so implementing effective client-side protection is key to ensuring the safety of customer data, the integrity of user experience, and the functionality of web applications. From a business and investment protection point of view, having a secure digital presence is a solid foundation that drives your company's ability to grow and succeed. Jscrambler provides multiple layers of multiple levels of client-side protection within our solution code integrity. From code to runtime, we offer a level of visibility and control that supports your company's innovation. With Jscrambler's polymorphic obfuscation, code locks, and runtime protections, attackers can't easily reverse engineer, debug, and tamper with your code. In addition to making the obfuscated code unreadable to humans, Jscrambler also makes it very resilient, meaning it would be very difficult for a machine to reverse engineer. And we touched upon it earlier. We know that it is increasingly common for attackers to develop programs to deobfuscate the code rather than to try and interpret it manually. So when someone tries to debug or tamper with your code, with the code protected by code integrity, our protection puts forward self-defense mechanisms and countermeasures to stop any kind of client-side attack. In addition to obfuscation and runtime defenses, our platform also helps with compliance, and you can comply with certain regulations and standards, such as GDPR, CCPA, as well as security standards such as PCI DSS version 4, NIST, OWASP, and PSD2. I have PCI DSS version 4 sort of highlighted on the slide because I think it's very relevant for those present today, as the implementation of the standard is scheduled for early 2025, which means right now is a good time to start evaluating solutions. Now, Jeffrey is going to actually show us a little demo about how our code integrity product works. So over to you, Jeffrey.
Thank you. See if I can get everything shared here. And what I want to do is just provide kind of a quick start for the code integrity product. I'm going to show the dashboard and show a project that I've already got uploaded. There is a free trial of this product available on our website, jscrambler.com. When you sign up, you'll be able to see this dashboard. It will walk you through uploading a project and getting started with the application. Once you get through that upload, you'll be at this screen here. And what we show is a lot of information around compatibility, frameworks that you might be using. Compatibility, of course, very important to us, making sure that your app always works. But I want to go over to the only JavaScript file that I have in this project, quite a small project. And this is a simple application, but in here you'll see the source code over here on the left, straight off the developer's desk, hasn't been minified, hasn't been processed in any other way. And then you'll see a protection that I did earlier. And I'm actually going to do a new protection here, which is very simple. Just by choosing some of the templates we have available over on the right-hand side, I can apply that template and go ahead and get a protection. It's very quick to get a version of the code that I can now test. So this protected code is a new version of the source over here on the left and is ready for deployment. This is still JavaScript code. It can be deployed in exactly the same way and manner that you had that source code before, even if it's part of a larger application, even if it's part of a larger web app, Electron app, hybrid mobile. It can go right back to where it was. And then you'll see some of the other options. I mentioned that obfuscation works best when you have a lot of different methods or techniques working together, and you'll see a lot of those techniques over here inside the fine-tuning selection, where you can choose what you do and don't want to protect inside of a given file. And then we've got our RASP features, which we mentioned, anti-tamper, some of the dead objects handling as well, where you can start to get into more of the active protections combined with the passive protection of obfuscation to protect your code. Once you've done that, it's very easy to integrate this into your CI/CD process. You can simply come down here and either save as a template inside the dashboard if you're testing multiple configurations, or you can import and export those settings to integrate them. Of course, this dashboard use of getting a protected version of the code is not how our customers use code integrity on a day-to-day basis, right? They integrate it fully with their CI/CD process, whether they're calling the services directly from command line or whether they have those integrated via a plugin into their framework of choice, especially when you're talking about Node or Vue, other Webpack-based frameworks. You can get that protected version in your normal run commands, right? Have that fully integrated. And from there, it's just deploying the protected version of the code instead of the source code, and you're up and running with an obfuscated version of your application. So I'll stop sharing here. There are other features as well when you get into the dashboard that show you what methods are causing the largest file size increases that allow you to tune further. There are options for tuning certain features or variables up and down to make things more or less sensitive. A lot of those you won't find in free tools that allow you that control over your protection. Yeah, I think Gustavo, back to you and move to Q&A, right?
Right, thank you very much. So we'll be soon starting our Q&A. Before that, I would like to thank you very much to our audience for staying with us so far, and also especially for engaging in our polls. And also a very special thank to our speakers today, Katya and Jeffrey, for all your information and insights shared. So yeah, now it's time to answer your questions. You can place them on the chat, please, and I will go through them. And yeah, we already have one question from Yuval. So Yuval asks, can you provide your best practice how to handle content from third-party in general ads while attacker may use obfuscation in code? You want to take this one, Jeffrey?
Yeah, and I think that's a great question. So it really depends on what consequences you're taking a look at. And the two that I would be concerned about is compromised content being served through those ads that might seek to tamper with my code, right? And then the other would be trying to pull information from the page. So in the situation where code that's from a third party wants to tamper with the first party code, with your own application, obfuscation and anti-tamper prevention are going to provide you not only some protection from that, but also the ability to detect if it occurs. You'll be able to see how common that is, those alerts, and make it back to the same dashboard that I just showed, and be able to decide if there's further action that's necessary, or if it's something that occurs here and there. The other consequence you may be worried about would be if that attacker is trying to scrape data off of a web application, whether they're reading data straight out of forms, whether they're modifying page behavior in order to send that to another server or a server they control. And that goes more into the full platform that we provide. Katya touched on at the end, that's around taking the third-party aspects and controlling what they are and are not allowed to do on the page. And this does not rely on being able to statically analyze the code, since we track behaviors in that situation, and can prevent certain vendors being able to touch that code. Other questions?
Thank you very much, Jeffrey. So we have another question from Paulo, and Paulo asks how different Jscrambler is in comparison with Obfuscator.io, which, for the ones that don't know, is a free online tool that obfuscates code. Who'd like to take this one?
I can give kind of a short overview. The biggest difference is going to be able to protect the project all at once, as well as compatibility. I think in the past, when we've seen people come to us from Obfuscator.io, it has been, hey, I have a build or two where everything is okay, and I can deploy my code, and then I'll randomly have a build that does not work. And I either have to go back and protect again, or I have to tweak settings, or I have to change things in order to get a functional build. Gustavo, you had some other things on that.
Yeah, absolutely. I can speak by experience. I personally know this tool, and our technical teams here at Jscrambler are very familiar with it. One thing that is very obvious when talking about this tool is the resilience and the potency of the protection that it applies. It's not so strong as the one offered by Jscrambler. And there's also another aspect which Katya also touched before. There are online tools there that can de-obfuscate code obfuscated by Obfuscator.io. So it's pretty easy for some attacker to do some Google search and quickly find something that can de-obfuscate Obfuscator.io. Whereas for Jscrambler, so far we didn't find yet any tool to de-obfuscate, suggesting that Jscrambler tool is much more powerful than Obfuscator.io.
And I believe we did a study not too far back where it's either Obfuscator.io or Obfuscate, the JS one, Obfuscate JS, where we could insert code obfuscated by them into ChatGPT, and it could get a good ways through the deobfuscation process and say, okay, all right, now that you're here, go through these 3 or 4 steps and you'll have most of the solution. And then with our code, it's like, yeah, I can recognize that this has been obfuscated, but I'm not really sure how to proceed. You could try these things, but they're just general information. So I think we'll provide a link to that article as well after this is over.
Exactly. Yeah, good catch, Jeffrey. That's absolutely right. So next question is from Rita. Hi, is it possible to apply different obfuscation techniques together to increase code security, and how this affects application performance? So you wanna take this one, Jeffrey, as well?
Yeah, and then I can grab the next one too. When you combine different methods, certain methods will work better together, but certain methods can also, say you're doing a lot with strings, say you're encoding them, you're also splitting them up, you do multiple things with just strings or variables, you can start to really inflate file size. And so it's advantageous to have multiple options, right? Maybe inside of our own product, we have string concealing, string encoding, string splitting, but maybe you don't want to use all 3. And in certain situations, it may be good to use 2. It may be good to use just 1 on its own. And it's important to test those, see what your code size increase is, and find a solution that works for a particular use case. If you don't have a ton of strings, it may be a good idea to use a lot. If you do have a bunch, then you may only want to use one or a few protections, and being able to tune things like frequencies, how often, how aggressive you do that encoding or splitting can also help with file size when you're tuning. And then you've all asked a question about how do you integrate the solution into the CI/CD process without manual steps. I'll take Node as an example, not sure of your particular framework. For Node, we offer a plugin that goes straight into the build process. So at the end of when you go to create a build from your Node project, you run your normal npm run build command that invokes that plugin as part of that process, which triggers the code integrity services and generates the protected build. That protected build will go back into a separate directory when it's done, and you simply change your deployment source directory from where you previously had either minified or otherwise processed code for deployment to the new directory. And so from putting in the plugin, putting in your settings file, which is generated by the dashboard, and then changing that directory, those are the three main steps. From there, anytime you do a normal build or kick off a Jenkins process or other automation tools, you'll get that protected build automatically, and then you can either choose to deploy it automatically, or there is a receipt that comes down with that code that you can read to look at statistics like build times, file sizes, and then if you want to make more decisions using automation tools from there, that's a process you can kick off using that receipt. Hope that answers the question.
Thanks, Jeffrey. So let's give some more time, just a little bit, see if anyone else has more questions.
In the meantime, I can actually share the poll results with you guys. Apologies for not sharing it later, but I think it's interesting. So the first poll question was, how many of you are currently using open source obfuscation tools? And the results are 67% said that they already used a tool like that a couple of times, and 33% said they never used an open source obfuscation tool. So it seems like we have the right people today, the right audience. And the second poll was about what concerns you the most about using free obfuscation tools. And 50% of you replied a lack of support and updates. 25% replied security vulnerabilities, and 25% replied limited features compared to paid alternatives. Yeah, so that's interesting. A lot of people are concerned about lack of support and updates. I think someone else was trying to ask a question. I'm not sure.
I think we're covered. I think we're good. So Gustavo,
yeah, I think we covered all the questions.
Good. Thank you, Katya, for the poll results. Good to see that we actually had some good results there and good engagement from our audience. And so we are almost finished. Before we go, I would like to once again thank you very much for coming today. And don't hesitate to reach out to us. In the future, you have our email address here. And we also have a page on LinkedIn, which I invite you to follow. And please take a moment to check our website, Jscrambler.com, and subscribe to our newsletter. You will get resources not only about obfuscation, but also from other topics related with client-side security. And you can also sign up for a free trial of Jscrambler at our website. And you will also get a blog article containing complete up-to-date guide to obfuscation and the brochure detailing the protections available in our code obfuscation product offering. Finally, after this session, we will send you a short survey, which we would very much appreciate if you could answer. And once again, thank you so much to our audience, to our speakers, and also to the amazing team involved in organizing this webinar. Bye-bye.
Thank you.
Thank you, everyone. Bye.